Our next champion is Dr. James Liao from Los Angeles, California. Dr. Liao is a Parsons Foundation professor of chemical and biomolecular engineering at UCLA. As a leading expert in metabolic engineering and synthetic biology, Dr. Liao has developed several microbial technologies for production of fuel and chemicals. Most recently, he and his team have created an integrated process for converting electricity and carbon dioxide to a gasoline substitute. He was also a recipient of the 2010 Green Chemistry Challenge Award. Congratulations, Dr. Liao.
Okay, at first I'd like to thank the White House for putting together this program. I'm truly honored and humbled by the peers that I'm sitting together with. And I'm here to sort of represent a larger team of researchers who are funded by Yi in a program called Electrofuel, where we try to convert electricity and carbon dioxide in the air to a form of liquid fuel that we can use directly in a regular car. We know that we can harvest sunlight to produce electricity in different forms, but electricity is difficult to store, even though battery technologies and various technologies have advanced tremendously. But we still want to have some flexibility to convert this electrical energy to a form of energy that we can use in the regular car. So we don't have to rely on a different form of infrastructure or different design of our car. So on that background, our team started to develop technologies that convert the electricity and carbon dioxide to a liquid form of fuel that we can substitute gasoline. And I'm very lucky to get it to work and be very happy to be honored in this panel. Thank you.
The first question of things that I know very well, or not really well, but synthetic biology, what he has not talked about is something that you're trying now, and correct me if I'm wrong. You know, all our biofuels, for example, or for that matter, food, comes from plants, the plant food and the biofuels. And that all depends on photosynthesis. And photosynthesis has a process in it called where it takes carbon dioxide and fixes it, something called the Calvin-Benson cycle. And our whole life on Earth depends on the Calvin-Benson cycle. And what Jim is trying to do is something intriguing. It turns out the Calvin-Benson cycle is very inefficient. The amount of energy that goes from sunlight to a biofuel is less than 1%. 99% of the sunlight is wasted. And what Jim is trying to do is to change that cycle from the Calvin-Benson cycle to something much more efficient, which will not only affect energy, bioenergy, but perhaps even food. And if that happens, you will be, I believe, the Norman Borlaug of the 21st century. You'll get your Nobel Prize and other things. No pressure on you. You'll save the world. So tell us a little bit about how you got into this. And what is it that was going through your mind that triggered? Was it because you wanted to do basic science and get into do something really interesting? Or was it the need for energy? Was it macro or was it micro?
This is a very important question and a very interesting question. I think most of us will agree that we're going to run out of oil sooner or later. Maybe in our generation, maybe the next, maybe the following generation. It's supposed to run out of oil. What are we going to get as a replacement? There are only a few alternatives, and we try to do it in a way so that we don't have to dig something out from underground. So the only option that we have is to recycle carbon dioxide in the air. So then we think about how many different ways to recycle carbon dioxide. And one of the most effective way is actually developed by biology. Okay? Plants, for example, fix carbon dioxide. However, plants fix carbon dioxide for its own purpose. It grows slowly, as we all know it, and it's not necessarily efficient enough for the kind of thing we wanted to do, which we want to make fuel instead of making sugars. So we started out thinking about the problem and trying to see where the inefficiency of carbon dioxide fixation comes from. And one thing lead to another. We investigate the detailed biochemistry. We figure out a potential way. I stress on potential because we haven't accomplished that yet. We figure out some potential ways to increase the efficiency of carbon dioxide fixation. And if that can be done, then as Dr. Majumdar said, we will be able to increase the food as well as the fuel output significantly. Thank you.
Great. I should say that, part of